Let's solve problem 1.32 from Microelectronic Circuits 8th edition by Sedra and Smith. To familiarize yourself with typical values of angular frequency, omega, conventional frequency f, and period t, complete the entries. This one's pretty straightforward. We're just trying to understand the relationship between our angular frequency, conventional frequency, and period. So if we have one of these values, we can find the rest. So omega is equal to 2 pi times the conventional frequency, and our period is equal to 1 divided by frequency. So let's start with case A. So we have frequency, so we can calculate t is equal to 1 divided by 5 times 10 to the power of 9 hertz. That is equal to 0.2 times 10 to the negative 9 seconds. And I'm just going to start writing the values in the table. Omega is equal to 2 pi times the frequency, 5 times 10 to the 9. That is 3.14 times 10 to the power of 10 radians per second. Okay, let's do case B. We're given omega, so frequency will be equal to omega 2 times 10 to the power of 9 divided by 2 pi. That is 3.18 times 10 to the 8. Therefore, our period will just be 1 divided by the frequency, 3.18 times 10 to the 8. That is 3.14 times 10 to the negative 9. Okay, let's do case C. We have period this time. So you can find the frequency by just reversing it. Frequency is equal to 1 divided by t, which is equal to 1 divided by 1 times 10 to the negative 19, or just negative 10, sorry. Negative 10. Okay, and that is equal to 1 times 10 to the power of 10. So then omega is equal to 2 times pi times the frequency of 1 times 10 to the power of 10, which should be 6.28 times 10 to the power of 10. Okay, let's solve for D. We're getting frequency. We can solve for period is equal to 1 divided by 60. That is, we're just writing in the table, 1.67 times 10 to the negative 2 seconds. And then omega is equal to 2 pi times the frequency of 60, which is getting 3.77 times 10 to the power of 2 radians per second. Okay, we have case E. Frequency is equal to omega, 6.28 times 10 to the 4 divided by 2 pi. That is equal to 1 times 10 to the power of 4 hertz. And then t would just be 1 divided by 1 times 10 to the power of 4 hertz. And that'll get us 1 times 10 to the negative 4 seconds. And then lastly, we have case F. So frequency will be 1 divided by the period. That is equal to 1 times 10 to the power of 5 hertz. Then omega is equal to 2 pi times the frequency of 1 times 10 to the 5. That is 6.28 times 10 to the power of 5 radians per second. And this table is done.